Hey guys, so I'm Swapnil and this is William, and so we have come from a very long distance, I guess. So we are here from Portland, and both of us work on Apache Geode, and so I've been actually working with this team for 8 years, and William is working for about 4. So yeah, so we used to be a product called Gemfire, which then got released as open source, and it is now incubating under Apache as Apache Geode. All right, so there was that. So in this talk, I guess we'll touch upon what exactly the project is, who's using it, why would anybody want to use Geode, and how do you actually go about using Geode, and then we'll touch upon an example with devs. So this is a conference for distributed event-based systems. Touch upon a solution of that. Touch up briefly on the roadmap, and then we'll have our Q&A. All right. So Geode is essentially a rock that you can break, and it has shiny crystals inside. And with this project, we're kind of trying to draw a parallel, saying Gemfire or Geode is actually our project is rock solid, and it really shines in the way it performs. So there is that. Last cheeky line, I promise. So how many of you have heard the term IMDGs, or in-memory data grids? All right. Okay. So
you know about Gemfire.
Well, and yeah. And how many here know about Gemfire, I guess? Okay, cool. So Geode is a distributed in-memory data grid. Essentially, it has persistence. It is, since it stores all the data in memory. It is really fast. It gives you enormous scale. It scales horizontally, and it supports event-driven architecture, and we'll touch upon all of these things as we go on. All right, so Gemfire, right, which is what I'm referring here, because Gemfire has 1,000+ customers already in production. It's just that last year, Geode actually came out, and just last month we have had our first release. So these numbers don't really talk about Geode numbers per se, but Gemfire numbers. But the core is the same. It's the same code base. So we've been developing this since 2004, and I guess I shouldn't really be going into any of this, but we have making progress, and a lot of large telcos, and I guess other companies are our customers. So okay, so here are just some of the numbers that I'd like to highlight. So GE uses Gemfire for their water and remote monitoring, and they store 17 billion records in memory. The Chinese railway and the Indian railways both use Geode for their online ticketing reservation system, and I'm sure you can read those numbers over there on the slide. So if you look at the population of China and India, you could say that the project touches is used by almost 36% of the world population. So if you are interested in working on a technology that gets used widely, feel free to contribute to Geode. All right, so here are So how many of you have heard about the YCSB benchmark? Okay. So YCSB stands for Yahoo's Cloud Servicing Benchmark, and so that benchmark gets you a few different workloads. Workloads which are insert only, and then insert and read only, and you can tune how many percentage of data you want to just insert versus read, and various things of that nature. So we ran the YCSB benchmark on Cassandra and Geode, and happy to report that we are by far more performant than Cassandra, as you can see from this chart. And so this is another benchmark that we ran. So this shows how Geode does actually guarantee horizontal scalability. So for this run, we started off with 2 Geode servers, and had 256 clients working against those 2 servers. From then on, we scaled up the number of servers, went from 4, 6, 8, and 10, and also scaled up the number of clients. And we see that we get a linear gain in our throughput, and with the latency and CPU usage staying relatively same. All right. So what makes Geode fast? So we have maniacal attention to avoid any object copying, or minimize all the contention points that are there. Everything in Geode is partitioned. So if you had a workload, then the good chances are your only partition, the workload actually gets run in parallel on multiple nodes, and that's what makes it faster. And when that runs in parallel, it is actually running in process with the server. So if you had user code, it runs in the process. And that also is one of the main reasons. We also try to minimize disk seeks where possible. And so one of the things we have is we have this internal benchmark which runs almost every week. And if there is any degradation in performance, it is caught and it is treated as a showstopper issue and fixed immediately. So that allows us to stay on the cutting edge of performance. To get Geode, you can go to the GitHub clone of our ASF repo, clone it, and build it very easily. This is how you would start one of the locators and servers. You can also use our Docker image to start gfish. Now, I'm going to actually try a hands-on demo explaining what all those instructions just meant.
And as with any live demo, so keep brain. So
right.
maybe increase the font size, I guess.
Is that good?
That's good.
Okay, all right. Okay, so I'm going to start gfish, which is Gemfire shell. It is going to be renamed to Geode soon. So now we are going to start the Gemfire distributed system. So in the system, there are you start multiple servers essentially, and you need a way for those servers to be able to discover one another. The way we do it is we start a different process called a locator. And so when you start a server, you only point that server to the locator, so that you don't have to really give the ports, the host names and ports of all the other servers to a new server that is starting up. So in practice, it just means it just is as simple as doing this. So we say start locator name and give it some name, and in this case I'm going to specify a port on which the locator will listen for new member connections. So there you go, we have one locator running, and now we are going to start a server. We'll call it server 1. And the cool thing about Geode is it has tab completion. So this gives you all the options that you can use to configure the Geode server. So you can do things like setting up the max memory, the number of connections that this server should accept. You could set up the cache XML file, which you'll be able to configure the server with, and things like that. So in this case, for the server, we are going to point it to where our locator is running. So in this case, it is on localhost and running on 1111 port. Okay, so we have our server running. I'm going to start one more server. So call it server 2, and for this guy, I'm going to say that the server port is going to be, some port. So that is the port on which the clients will talk to the server. You have created 2 servers and a locator. So just make sure that is the case. If you do a list members, sure that those 3 processes show up. Now, in order to store data in the server, we create something called a region. You could actually say, well, you could consider the region is equivalent to what an RDBMS would call a table. So in case of Gemfire, a region is essentially a hash map. I'm going to just say my region. And so again, on tab completion, you have all these options that you can use to define your region. We'll touch up on a few later in the talk. So the most important of these is type, and these are the types of regions that you can create. So, there are essentially, 3 main types of region, and rest of all is just additional configuration options that you can have on those regions. So you can have a local region, which is essentially not distributed to any of the other members in the system, but you can have eviction and persistence to those regions. So that essentially gives you a hash map with persistence and eviction. The other type is replicated. So if you have reference data, which could be small but needs to be replicated on all the members of the system, you can use a replicated region. And the third type of region is a partitioned region. So this type of region partitions the data amongst all the servers in the system. And then you can have partition, persistent, overflow, and all those other options. In this case, we are just going to say that our region is going to be a partition region. So there you go. The region is created on those 2 servers. Now, we are going to load up some data actually, and so earlier I actually created this file which is going to load up about 300 keys into our region. So the command essentially here was put the key, and in this case, the keys and values are both strings. So it's pretty simple, I guess. And now we actually can say, show metrics on region, my region, and also give it member and say server 1. And what this tells us is that there are 148 entries on server 1 of the 300 entries that we inserted, and on server 2 there are 152. Alright, so now I'm going to demonstrate what happens when we start a third server into the system. So start server, name is server 3, server port is going to be another port, and so when this happens, the data is going to rebalance, hopefully equally amongst all three members in the system. Now, note that, however, when we start a new server, Geode doesn't really know if there are going to be more servers started. So we don't eagerly rebalance the data, because so say in this case I had to start 3 more nodes. Then we don't want to kick off data movement 3 times. So Geode really doesn't do anything unless when you start the server, you provide this additional rebalance flag. And that will kick off rebalancing and distribute the data hopefully equally amongst all the servers. So if you run the same show metrics command now, we see that there are 101 entries on server 1, 99 on server 2, and 100 on server 3. So that's how you can just add capacity to your system and keep on scaling the system.
Any questions so far? I mean, please don't be shy. Yeah.
Yeah.
Wonder?
So if you didn't do a rebalance, if you didn't specify the dash rebalance, what would have happened in that case? Would the new server have taken on new entries? Like how would the data have been?
Well, the new server wouldn't have really done anything. It would just sit there.
Let's talk about port memory.
Yeah, you can.
Let's do a quick demo. Why
Sure,
not?
do a server 4 and no rebalance.
Let's do a server 4. Oops.
Start.
Oh yeah. So start server. Don't do a rebalance.
It's nice to do things out of this script. 5 demos.
Let's start a server 4. Okay.
Programmers that live days.
Started.
Yeah, right.
And if
What could
now-
go wrong, right?
If now you added a bunch of another 300 records, it would span across all 4 of those.
Show us it's empty. Yeah.
Yeah,
We can see what happens.
Sure.
Yeah.
There you go.
Empty.
It's empty.
Yeah.
And
Pick a rebalance now.
yes, and so you can always kick in a rebalance
Oh.
at any point, and it gives you a nice summary of what it did, how
You can
much time
even-
it took.
You can even simulate the rebalance because, I mean, imagine that, of course, here we're just playing with like a small heap, right? But in production, and as most of our customers do, they can be running this with like, I don't know, 100, 120 gig heaps or stuff like that. So you may want to simulate first what a rebalance will do in their system and then actually kick a rebalance just to avoid any trouble in production system or anything like that.
That's how you would do it. And having done that,
Well,
now it has 32 entries or so. Yeah.
so the rebalancing is based on the number of the records or based on the size of the data?
So right now it is based on the size of the data actually. So you can, the rebalancer, so there is an API that you can, or there is a plugin basically that you can have into Geode, and you can program and you can actually tell us what criteria you want to to use to be able to rebalance. The default criteria used is the size of the records.
Okay. I'm sorry, the other question was, if you don't do the command line rebalance and instead there's new records coming in, will that trigger the rebalance?
No. So I should, well, at this point, I should, I guess, dive in a little bit into how
Okay.
data is actually
Sorry.
stored in the partition region. So in a partition region, we, just like in a hash map, we have what are called buckets. And so by default, there are 113 buckets, but even you can configure that when you start up a partition region. And that bucket is the unit of data storage in a partition region. So when you start up a new server, it is going to get a subset of those buckets, essentially. And so the bucket moves in its entirety to the new member. And the goal is to have an equal number of buckets on all the members, provided your hashing function is implemented correctly and all the buckets have similar data and all that good stuff.
So if you don't reapportion them when you create a new server, you create a new region and say create a new partition region, it will
Yes,
all
yes.
be
Evenly, yeah.
Yes, that will create an empty region on all the members that are up at that moment, and then, yes, whatever new data you put into that new region will get, yes.
Oh, but the old regions won't. Oh, if you put.
But the old regions won't
be out of balance.
until you
It's like-
kick off rebalance. So there is one project which is, I guess, not GA ready, but it's kind of it's almost there.
Yep, it's
and
in
it's called it is in Geode, and it's called Auto Rebalancer. So that thing, just monitors the system, and whenever new members come up or the heap gets totally out of whack because the hash function you implemented is not correct enough, and there is skew, it will then automatically trigger a rebalance.
So it keeps monitoring the health of the system and the buckets and whatnot. And if it becomes unbalanced, then it triggers a rebalance for you. But that's fairly new. It's considered experimental in Geode, but it's there. Yeah.
Yes.
I guess it's time to move on to the writes. Where do the writes go? Any of these nodes? Or my request to write, where does it go to?
It would, sure. So in a system, so when you start a partition region, you can specify redundancy, I guess, how many redundant copies you want for each bucket. And then the primaries, I guess, are also, so any copy of the bucket can be a primary, and so there's always one primary copy on a node and then a secondary copy on a different node, right? If you had redundant copies 1. And so when you try to write something, it first ends up going to the primary node. From there it is replicated to the secondary node, and only when it is completely replicated does your write return. So we guarantee that it is replicated to your configured number of redundant copies before the write ever return to the
That's the only
application.
mode it has. Let's make sure it's in all the copies, and then we'll get back to you.
Well, so for partition region, yes. If you were using a replicated region, then there is a no ACK mode essentially. So that would make sure that it just writes locally and then that's
It
it.
gets back to you, then eventually gets back to the replicator.
Yes, yes.
Do you persist this data at some point?
Is that?
Do you persist this at some point?
Yes. So if you look at the create region options, right? Name is, I'm going to just say foo, and the type. So if you look at the types of region that you can create a persistent region, and that would guarantee that all your data keys as well as the values are written to a disk. You can also just configure this thing to overflow data to the disk. So when creating a Gemfire server, when you start a Gemfire server, you can say, monitor the heap for me, and when the heap exceeds, say, 80%, at that point, start overflowing data onto the disk. And this is what will enable you to do that. Yes?
I have two questions. Are you able to make use of off-heap memory?
Yes, in Geode you can use off-heap memory as well. So that also is a command while trying to start a server. So while starting a server, you can say, I am not seeing it. Do you see it?
Off-heap memory size, it's right there. It's the third column.
Before you might overflow to disk, you could take advantage of off-heap memory.
So no, the way off-heap memory works in Geode is when you use off-heap memory, everything is off-heap.
Okay.
Except the keys.
Except the keys, yes. All your values.
Oh.
All your values are off-heap.
But you can still, but at that point, then you can't overflow through.
You can. You can. When you run out of your off-heap memory, you can overflow to disk.
So is the common paradigm where you have all your data is in memory and it's redundantly on disk, or do people ever use Geode in a way where just some of the data is in memory because there's only so much space in memory, but there's a ton more data on disk?
Well, I believe
Both are very common. I mean, it depends on the use case. So some people actually say they want the hot data in memory all the time and just the cold data in disk, or even persisted somewhere else if you want to. But then there are other use cases also, of course, that they want to keep in memory just until it reaches a certain threshold, so memory or number of entries or something like that.
I mean, but is it built for one use case or the other? You're saying
It's built for both.
You can use
to
both.
support both, actually. And the thing is, because originally, right, as you may think, actually, we briefly talked about that too, but the history of the product, right, it came from the financial industries, right, so banks and whatnot, and then a few customers would have a certain use case, so we'd provide the feature for that customer, which might be keep the hot data in memory and then persist everything else to disk. But then another customer has a completely different use case, and nowadays, I mean, it's not really that much focused on financial industries anymore. So we're actually expanding. I mean, of course, web applications and whatnot are also using Geode. So then we are kind of now, of course, implementing the other features to support both use cases, right?
Yes.
Kind of weird.
So you said that you keep keys in memory. What about indexes?
Indexes are also in memory.
For now.
For now, yeah.
So
Well, even the keys are only in memory for now because we're planning on getting rid of that as well. So we're planning on getting the keys to also overflow out to disk.
I'm not sure.
It will be configurable.
Yes.
If you don't like, there you go.
Yeah. If you want,
If you don't like it,
in the
disable.
interest of performance, if you want all the keys in memory, then sure, you can have that.
Yes, there was here and then there. Yeah, you can.
When a server does, is there a process that guarantees redundancy? Is the rebalance automatic, or do you have to manually?
It is automatic. If a server dies, then the rebalance is automatic.
If you configure enough copies, otherwise.
Yeah, well,
Yeah,
you can have a partition region without copies, right? You can just partition region. So if you don't have redundant copies, then you lost that data. But the normal use case for a production environment, of course, would be to set up some redundant copies, right? So then it's going to reestablish the copies with the current nodes it has to.
Can you describe the total servers in, for example, one of these railroading systems? Is there one set of all these servers that is everybody on their mobile phone, I suppose, or some kiosk is all talking to one place with people and trains and seats and other such caches?
Yes.
I just made those up. But
Sure. So as far as I'm aware, right, the Chinese railway is actually running just one primary cluster. So every user request is hitting one active cluster. Then I'm sure that they actually have a backup, which is
Well, yeah,
a passive.
behind the scenes, there's replication and all this, but as far as, it's not like I'm going to the regional place and it's replicating to some super region.
Well, that's how the Chinese Railways is doing it. But in Geode, you can actually configure, so a bunch of servers that form a distributed system can be configured to replicate to another distributed system through a WAN connector.
So you theoretically could have servers per state and then a central.
Actually, people do that like over regions, like continents. So we do have like customers that do that, like they have one cluster in US and another cluster in Europe and another cluster in, I don't know, Asia, and they're all in sync or becoming in sync through a WAN gateway, yeah.
Yeah, through WAN gateway. So our financial customers, they typically had an office in London, Tokyo, and New York, right? And if you end up reading Gemfire documentation, in the WAN thing, all the examples actually say London, Tokyo, and New York.
Well, I asked a concrete question, so that would be a great example for me. It's like, oh, I see 3 cities distributed,
Yep.
and all the data replicates around.
Exactly. And you can then also choose, those clusters to be active and or active passive. So if you make a change in the London cluster, do you want that to be reflected in the Tokyo cluster, right? And vice versa. So do you want that, or do you just want one star?
All equal, or
Yes.
whatever.
Yeah,
Yes.
yes. And then you can like plug in conflict detectors in the middle. So if, for example, someone in London or in Tokyo like change the same entry, so you have this class that you can implement to resolve the conflict if a conflict happens. We do have our own, but sure you can implement our custom too.
Yeah, our own tends to be based on timestamps.
Yeah.
But you can provide more logic to it.
Is there any kind of validation going on?
Validation.
Validation,
Um,
amongst the servers, the data is,
You mean
distributed.
monitoring the case of the
replicated,
health? Okay, yeah, yeah. Yeah, we do have. Go ahead. No, you can go.
Well, so each of the entries that you insert into Geode gets its own version. And so, that version information is actually shared amongst all the servers. And if, on a replicated region especially it matters, because then eventually the replicated regions can become consistent with one another. So that is going on.
Based on a Microsoft paper, vector plots.
Yes.
Artifacts, that's how we call it, yeah. Those are very good questions, actually.
Yeah, awesome. I think we actually, covered most of the talk.
Thank you very much. No, okay. no, that's it. Keep
All
going.
right, so back to the slides, I guess. If only I can click, yeah. Okay, so we talked about a few of these things, and I guess we should now dig a bit deeper into what all of these things mean. So, when you start a Gemfire server, you're essentially, creating what we call a cache. So we came from a caching background, so you still, say you create a cache, but it really, is not the case anymore. It is persistent and it can be used as a store of record, but just we stuck with that name for legacy reasons. So a cache, as we saw, is a collection of regions. You can create multiple regions in a cache. You can configure a cache through an XML file. There is a Spring project dedicated to Gemfire or Geode called Spring Data Gemfire, but it works on Geode as well. And so you can use that if you're using Spring for doing your app development. And there's obviously API that you can use or to be able to configure your cache, or CLI as we just saw. Again, a region is a map, essentially, a concurrent hash map. So You also have the concurrent map operations like put, replace with old value, new value, and all the stuff. Regions are, you can configure redundancy and you can make them highly available. You can also store them. You can configure them for doing overflow or be persistent on disk. Well, yeah, that's what I just said. Yeah.
Speaking of the disk, have you implemented yet, or have plans to implement pluggable storage? So right now, when you're dumping in that PTX binary format, it's like almost a black box. Is it possible to plug my own storage so it will persist in JSON or whatever my favorite flavor of data?
Yeah, we're not there yet. So.
And also, if you be answering that, what about the bulk load? So I remember one of the problems we had that you don't have the bulk load API. Did you remember that?
What do you mean by bulk load? So there is, there is a put all operation because it's a map. So there is a put all operation, and you can, if you want to do a bulk load, you can definitely use a put all and have a bunch of keys.
That triggers a whole bunch of listeners and tries to persist back to the database.
Right. Okay.
There was no bulk load that would say, well, we're loading from the database, so no
don't
need to trigger all the audit and replication and all that.
Yeah, that's something that another product that actually we also had, Gemfire XT had, which was a special connection that you would establish and say skip the listeners. So you would specify like a property for the connection. So that particular connection will not trigger the listeners to not do that. But for Gemfire, we still don't have that property in place. But that's definitely a good thing.
And you still did not merge those source trees?
No.
You have those plans, right?
Yeah.
Still
Eventually.
No. Yeah. Not anymore. Yeah.
Technically, the product is open source, right?
Yes, absolutely. And both the products are open source. Actually,
There you go.
Gemfire as well as Gemfire XT, both are open source now. All right. I guess I touched upon all of these, and this is the list of all the regions that you can configure. Okay. So persistence. When you're using a persistent region, we use a write-ahead log where all the data is written essentially. The one thing I'd like to mention here is, so when we say we write to the file system, when we write to the disk, we are actually writing to the file system. And we're not f-syncing to the disk directly. That would just kill the performance. And we think it is safe to do that because normally you would have a redundant copy anyway. So if a node were to die and that entry was not replicated on or not written to the disk, it is available on the other member, so you should be fine. But in case you're not, then you can tune this thing to f-sync to disk also. So let's dig into a little bit on how persistence actually works, I guess. So the persistence is shared nothing, and so everything is written to local disk at all times. So consider this scenario, right? So consider that you have 3 buckets which are distributed as shown. The red buckets are the primary copies of the buckets, and then the yellows are the secondary. So if a node were to die, the buckets are, so we end up creating the buckets essentially on the members that survive, And I don't know if you noticed this, but the primary for V2 moved from server 2 to be on server 3. So each time we create a bucket on a new node, there is an election process that happens saying which copy should be the primary for a given bucket, and the results could be random to begin with. But then also, I guess if rebalance then occurs, then the primaries are also balanced across the entire system. So this was the case when one of the member dies, right? We recover the redundancy essentially, so that there are redundant buckets. So now let's say that all the members have died, or you have shut down the system essentially, and after that you start up server 1. So when you start server 1 still has the old data persisted to its disk. And it would be bad if it says, hey, I have the latest data and you can read, and that would be inconsistent. So what happens is that we have the membership view that everybody persists. So in this case, what would happen is server 1, when it starts up, it would say, hey, what was the view, or were there other members essentially in the system before I died? And in this case, the answer would be that yes, server 2 and server 3 were alive when server 1 died. So server 1 will not allow users to read data from its disk stores, because newer data could be there potentially on those other 2 servers. But then when you start both these other servers, then server 1 says, I have part of the data. Here is the latest version vector of the entries that I have, and it sends that to the newer servers, according to him, the newer servers. And then those servers then iterate over their local data, figure out which entries needed to be sent to server 1, sends only that subset of the entries, and then the system is alive once again and back online.
Who's responsible for generating the set of numbers?
Who's responsible? Could you repeat that, please?
Where did they get the set of members from?
The set of members is actually, so every member is aware of all the members that are there in the system at all times. And that is the information that it persists to its disk. And as soon as there is a change... Is that?
But server 1 was dead when server 2 and server 3 went down.
Yeah, but when server 1 was, so initially when server 1, so everybody in the system was alive, right? So everybody would store the knowledge that, there are 3 servers in the system, right?
So last thing he knew, he had 3 servers.
Yes.
I went down before 2 others.
Yes.
Therefore, I can't be the first one back up.
Exactly.
2 others have to come up first.
Yes.
Server 2 comes up and goes, oh, wait a minute, there were 2 of me. What's his decision? He says there was 2 and 3.
2 and 3. So even in that case, right? So server 2, even if, in the event that, they fail simultaneously, it's not really simultaneous. You could still have messages which are going across to the other guy saying, hey, this member is about to go down, essentially, right? So so at least one server would be able to come back up.
There's an order there that they recognize that they wrote on the way.
Yes, yes. And in the very rare corner case that they happen to die exactly at the same moment without telling one another about what was going on in the system, they would actually wait for the other guy to come on back up, because
and start asking, what do you got?
Yes, yes.
So I vaguely remember that was kind of a problem in the development. Let's say if I had 2 nodes, okay, and they both have redundant copies. So when I restart, I just don't want to start the second node. Looks like if I start accidentally the node I killed first, then I'll be waiting forever.
Well, you can manually do the revoke to ignore all this check, right? But by default, we are going for the safer route, which is to indeed check the other node.
So you can force server 2 to be the only one there when people be happy.
If you want to do
yes,
that
if
manually.
you want to, yeah, you can say don't care about the other guys, come on back up online.
But in a safe scenario, in production, if by whatever reasons, one of the guys cannot come back, then the system will be just hanged.
Well, you can do that even in production when you start up a server, actually. So there is, on GFish, there is a command to list all the missing disk stores, essentially. So, and you can revoke any of the members that you think does not have data or is not able to come back for any reason. As long as you have a copy of that data on another machine, you're fine.
And the
It's
startup will
a still
continue.
manual operation.
What's that?
Is it still manual operation?
It is a manual operation. Because we cannot decide for you if you are okay with not being able to recover that data, I guess.
Well, theoretically it could help because you know if it's a full data set or not. So if, let's say for partition data and if there is enough copies, you know if it's stored or not.
We don't know the latest copy though, right? So if a primary were to go down, the primary could have an entry, that the secondary copy does not have.
Maybe follow
Potential.
up discussion afterwards.
Sure. Okay, all right. So moving on. So on each member, we have an operational log. So this is the actual file, that we create in a file system. So this is an append only log. So whenever you make a change or you insert an entry, it gets added to the end of the file, and that avoids the need to do a disk seek and try and update the entry in place. So the way compaction works is we actually read through the old file, and so in this case, right, key 1 is there in our oplog 1 as well as oplog 2. So oplog 2 is our latest file. So we essentially have one file that we keep on writing to. When we hit the limit on how big the file needs to be, create a new file, start writing to that. And for doing compaction, so in this case, we actually have a newer version of the key in oplog 2. Hence, while trying to compact, we will not move K1 from oplog 1 onto the new ones. So the keys that were missing are copied forward, and now oplog 1 is all garbage and can be deleted from the file system. All right, okay, so on to the types of members.
Sorry, one quick question before we move on.
Yeah.
How often does compaction occur, and are there any impacts to the runtime of the system when that's happening? It's not like a memory defragmentation problem, right?
It's not like a memory defrag problem, no. And you can schedule when the compaction gets run, or you can run it manually. It's configurable.
So there's not like a huge impact to the system as it's running as we got back to the same time?
No, there isn't. So, one thing that I think I skipped over was when you write something to the persistent file. So, as we mentioned, the keys are always in memory. So, along with the key, we have a small pointer to the exact location in the disk where the value for that key is going to be. So if you know that, then compaction will have no impact essentially, except for disk thrashing maybe a little bit, but should be okay. Low overhead. Yeah. So as we've seen, touching up again on the kinds of members that there are in a system, there is a locator which is used for member discovery. Servers are the ones that actually store the data. And then there are clients that you embed within your application. Right, on to next. So the clients can be either thin clients or thick clients. So the clients themselves can cache data locally. And the cool thing is, even on the data that is cached locally, you can run OQL queries, which is nice, I guess. And when you have a thick client, the client that has data, it gets notifications from the servers whenever the data on the server changes. So there are actually two kinds of notifications that the client can get from the server. There is a register interest. By that, I mean is, you can say that as a client, I'm interested in this set of keys. And whenever those keys are updated, send me the value. And that could be either an actual set of objects. It could be a list of strings if your key was a string, or it could be a regular expression representing your keys. If you want notifications on a specific value, then you can use a continuous query. And so, well, here is an example, right? So select star from trade order region where price is greater than 100. So if trade order was a region, and it has the value has an attribute called price, then your client will get notifications when that price exceeds 100. So this allows you to do event-driven programming.
One quick bit, I guess. We haven't really introduced yet OQL, but it's the query language that you can use to query data in Geode. So you can do, of course, the gets from the map API and whatnot, but you can also query data using that syntax there, which is it's similar to SQL, right? But has some limitations. It's not exactly SQL, and it's pretty powerful. I mean, you can even do group bys, order bys, and stuff like that too.
Yeah, and you can drill down into objects. I guess we'll touch a little bit on that later. So these notifications that a client can get can be durable as well. So you can configure them to be durable. So what that means is when your client is offline, it won't miss any events. So the server will end up queuing all the events for the client when the client goes offline. And when the client comes back, the server will end up sending all those events back to your client.
So did you say that you don't have OQL yet? Or
we do.
No, we do.
We do have OQL. Okay, so so we have this thing called as functions, which you can think of as being stored procedures, or even MapReduce, kind of a MapReduce, I guess, for data that is actually stored in Gemfire. The one good thing about functions is they are run in process with our servers. So unlike MapReduce, it's not a different process trying to access data from a running HBase node. They run in process and hence iteration. And since all the keys are in memory, iterating is faster and you have quick access to your data. They can be, well, I guess. Let's jump to this one. So you can actually trim on where the function can be run as well. So you can say, if I were to explain this example by use case, say, I have to do, say I have a customer region, an orders region, and I want to update my customer status based on the orders that they have, and I only want to do it for specific customers. So I don't want to essentially run this function on all the nodes. So while running the function, I can say, run this function on the region and give it the name, and also with filter and give it a subset of the keys. So this function will end up running on only the nodes that host the data for those given set of keys. And you can get the results back from, you can even stream the results back from that function execution back to your client. Okay, and we have, as was, I guess we touched upon a little bit, we have callbacks that you can implement. There are cache writers and listeners. So the writers are triggered before data is inserted. If you wanted to massage some data or do some transformations, you can do it on the writer. The listener is invoked after an entry has been updated. So you can then go and update your backend database or whatever functionality you may need. We have an async event listener as well, and I guess so. William will talk about that in his demo. HA. So we take availability really seriously. So as we touched upon, failing copies are replaced transparently. If your bucket, if a member fails, the buckets are recreated on the other nodes. If a function fails, that function is also run on the other nodes parallelly or transparently to the user. Many a times, if there is a problem in your networking, what may end up happening is, say if you have 10 nodes in a cluster, and if the network is disconnected from the middle, so that you are left with 5 nodes on each side, both nodes, if both sides continue operation, they tend to get out of sync, and you will get wrong results based on which side a client is connected to. So to avoid that problem, in Geode, what we have is all the members have weights. So locators have different weights as compared to the other members. And on each member failure, a view gets sent out to all the members saying, this is the new view. And if in one particular view, if the weight of the system changes by more than 50% of what it used to be, we declare a network partition. And so with this, there is one winning side and one losing side. And the losing side essentially shuts off for operations. The servers are still up, but they will not answer to your put requests or get requests. They're essentially in a suspended state. When the network heals and they are able to talk to the healthy side, they again request for the subset of changes that happen on the healthy side, get the changes over, apply them, and the system is back to working condition again. You had a question?
But part of the network has some of the keys, only part of the network.
Yes.
I mean, the 5% to 10% set of keys is over on one of the petitions, and so is its backup. Maybe, it goes down. Nobody has the data.
Yes, nobody has the data. So, but what we know is, there was a member that was hosting the data, right? So we don't actually create the key locally, but we throw an exception saying, hey, I don't know what happened to that member, essentially.
So somebody asks on the live side for that data, they get an error that says, can't get it. Sorry.
Yeah, well, that would happen if, both, or, if all the redundant copies were on the losing side.
Yeah.
If you had at least one copy of the data on the winning side, you're fine.
And what if it drifts down into split brain and starts, you said, oh, I'm 40% down. Oh, I must be split brain, but 90, yeah, that's not split brain. 80, 70, 60. I mean, how fast does it have to split before you go, I think we're getting split brain here.
Well, for declaring a split brain, it has to be one membership change. So I think it's, timeout is like, for memory detection is 5 seconds. So within
You can
5
tweak
seconds,
that.
if you lose,
The whole bunch of.
yeah, then it is a split brain.
And also to avoid the key problem that you mentioned before, there is another concept called availability zones that you can also set up. So if you know that there is some whatever router or something in between those nodes, so you can create a cluster and say, hey, whenever a key gets sent to one availability zone, so I want the copy, of course, to go to the other zone. So to kind of try to prevent that. That's
So
one
it's
thing that you can do.
Secondary copy is usually across the wire on the other side? Is that
If you
what
want
it
to,
is?
yeah.
If you want to, yeah.
If you
can
want
do
to.
that. Yes.
So what happens to the kind of a MapReduce jobs? Let's say not the MapReduce, but the function that I normally run by broadcasting and gathering the results. So I always think I always investigate the full data set. Right? So in a split brain scenario, obviously some portion of the data is not available. Will be there any warning? Because all I do is just run on all nodes and give me results. And I expect that I'm running against the full data set.
I don't think so.
Yeah, I don't think you get
Yeah.
any warning.
I don't think there is any specific flag or thing you can check inside the function.
Well, if you, so as part of the function execution results, you actually get a list of all the buckets on which your function ran. And so you could, look at that, I guess, figure out if there are any missing buckets. I'm
Yeah,
not sure about
something
getting
system
a
offer.
Once you count buckets, it's kind of a low level stuff.
Yeah,
Sure, yeah, that's
absolutely.
something that the system
Absolutely. Yes, that's
doesn't treat. Yeah, it's a
we
very
should-
interesting
we
corner
should look
case.
at that too. Yeah.
Yeah. Good idea. Please submit the pull request. I mean, or the Jira
just
at
file
least.
a Jira,
Just
yeah.
file a Jira. It's actually a very good
When
one.
does the function report completeness?
When?
When does function report completeness?
So on a function,
It calls the last result.
Yeah.
yeah. So
There is a special call, so it can stream the results and there is a last result.
on the function side, you can, when you're trying to send results back to the server, right? You can
We take this offline.
take it offline.
Okay,
Sure. Okay, so I guess I also touched up on this thing. So yeah, we actually ended up touching upon the WAN aspect. So your data can be replicated to a different WAN site in an active-active or an active-passive manner. You can have all sorts of configurations, from hub spoke to star to whatever you want, essentially. The data is local, and even if the client is not available, when it comes back, it will get all the events that it missed. So I'm going to take up from this point onwards.
Okay.
Thanks, guys.
Sure. Yeah. So you'll be around. So now just talk a little bit about one of the features too that we have, right? It's called PDX. So one thing that when you talk about this key value stores, right? Is it fixed schema or is it a flexible schema, right? So you can think of it as like a JSON object or as a table, right? But one thing that we offer, it's something called PDX, although people, of course, the product was built in Portland. It's not exactly about Portland, just, right, portable data exchange. So the idea is that you don't have to worry about schemas. You can make your schemas evolve. You can version your schemas across different nodes. So there is a registry. There is a notion of a registry also. I think it's on the other slide about there's a registry that is distributed across all the nodes. And the way we store data and then you manipulate data when it's persisted using our serialization mechanism, PDX, it's very efficient because you don't really have to deal or to deserialize the whole data object. For example, let's say you are running a query like this. So select, so this is of course an OQL syntax, very similar to SQL, right? And you are here getting all the objects from the region P, and you are getting the other object pet under the person, right? And then also you have the dot type, so it's a field, for example, right? In this particular case, for example, we would be deserializing only the type field and not the whole person object in order to do this comparison here, right? So this is just like yet another thing for performances and for performance reason, right? And if you compare the PDX serialization with other traditional off-the-shelf serialization mechanisms, of course, Java is the worst. I mean, no news here. But then there is the bzone Avro, right? Protobuf, and in Gemfire, then you have our Geode, right? We have data serializable, which is the more how can I say that? You have to do everything manually, right? You have to hard code all the bits and write. So we pretty much have to do that and write the serialization, like the fields you are going to write it in the order and everything. But you can also leverage the PDX serializable or even the auto serialization, which is good enough for most of the use cases, I think, and has a very good performance too. So this benchmark was executed using this tool. So it's on GitHub. It's a project that benchmarks a bunch of serialization mechanisms, and we did that. And there's an article actually on Pivotal blog too about it with all the details. So talking about schema evolution, right? If we do have time, I'm not sure about how we are in time, but maybe we are good. There will be a demo kind of talking a little bit about how we deal with schema evolution in practice. But the idea is that you have this type definitions register, right? It is spread among like all the nodes. And then you have an application that connects to the cluster and say, hey, I'm using the object view1, the person view1 that has, I don't know, 4 fields, let's say. Then, for some reason, right, you go there and say, hey, I'm actually adding a new field to this person object, right? But now you have that other application that is still running, and you don't want to go there and stop that application just because now you have added or removed another field from the cluster, right? from the object. So what we do then is that we keep the version in this registry, and whenever an application view1, the application number 1, talks to the cluster, we say, hey, he's using an older version of the object. So I'm going just to send to this guy the older representation of that object as well. So I'm not going to send the field that it doesn't know about. And if there is a field that is not anymore in the system, of course, then I'm going to send no. So the value, of course, is no, but you're not going to throw like any exception because the field's not there or something like that. I mean, it's just a no. You have to treat that, of course, yourself. But then if a new version of that application connects to the cluster and talks to the system, then the system detects and say, hey, this guy is actually using the v2, the different version of this object, right? And now I know that I can then send all the fields, right, for the domain object to this client, to this application. So that's a nice way to allow evolution, like forward and backward, right, of your data models. Hope we can show the demo about it too.
How do you detect which version the application is asking for?
So when you connect to the cluster and you do your first operation, with that operation, if you are using PDX, you need to exchange that metadata with the cluster. So we then detect, hey, you're sending the person object with these fields. I detect that I know this on my registry, which is view1. So whenever I'm responding to that request, I'm going to use view1. Swap is here to keep me honest. Adapters, you want to talk about that? I don't know much about the Memcached. We could, please. This is something I guess it's more, yeah.
Sure. So,
I know a little bit about it.
So in Geode, we have protocol adapters built for Memcached and Redis. And what that means is you can actually take your Memcached clients or Redis clients, point them to a running Gemfire server, and it just works. So
That's the same, right?
Right, so the advantages of why you would do it for memcached is, with memcached, it's always a side cache essentially. So your application is changing the database and changing memcached, and there are race conditions that can happen and failure conditions that need to be taken care of, and it's very difficult to get it right. If you were using Geode, then it actually sits between your application and the database. So you can say, only if there is a cache miss in Geode, go and load the data from a backend database and put it into the cache. So that gets rid of all those error conditions that could happen in a traditional memcached deployment. We also have a protocol adapter for Redis, and there are actually two main advantages, and both of them are scale. So in a Redis server, if you have a linked list or a sorted set or any of the Redis data structures, they do not scale beyond the memory of a single Redis server that is available. You can have one more data structure, but that's not really making your existing data structure scale. So if you use the Geode implementation, those data structures are actually backed by a partition region. So all you need to do is just spin up more servers, and the data just scales horizontally, no problems. And the other scale advantage also is that the Redis server is single-threaded, which also, so you're not really able to utilize all those beefy server class machines that you may have. And if you use Geode, then Geode is highly concurrent, and so you also get that advantage. You also should be able to use our WAN replication to have a remote side and replicate all the Redis data onto the other side and all the good things like that.
So you mentioned about the Redis data structures, and I was thinking, do you have sort of first-class support for various data structures besides just here's the map and it's a map of maps?
That is actually in works, I guess. So in order to support this, we have an implementation essentially that has or supports linked list, right, and supports a sorted set. But right now you can only access them through a Redis client.
So behind the scenes you're representing it as
a partition region.
Okay.
It is backed by a partition region, and we are working on just adding native Gemfire API so that in addition to just a map, you will actually have a linked list and you will have a sorted set APIs in Gemfire or in Geode.
And that would be supported by OQL then?
Well, I guess that's still still up in the air, I guess.
And that's through the Redis API only.
Yeah, for now it is only the Redis API.
So I can take my Redis clusters right now and swap them out and not change my code, ideally? Oh,
yes.
Neat.
The adapter speaks Redis.
I like it.
Yeah.
I like it a lot.
All right, so back to William.
Yeah. So here we're going to talk a little bit about the devs challenge, right, and the implementation that we did to solve the problem, right? So I'm going to talk more about what devs, but the idea is that we are going to do a taxi trip analysis, right? And of course, in order to prepare the talk, we grabbed a lot of taxi drivers, cool pictures, because I think you guys would love that, right? I don't know why, but just did it, right? So talk a little bit about devs. Devs is an ACM conference, right? The name itself, of course, stands for Distributed Event-Based Systems. Every year they publish what they call grand challenges, and then most of the time I think it's the students. I'm not sure if companies actually submit things. I don't know. They do, right? I don't know. Yeah. So, but they then submit like papers to solve those challenges, right? Which usually are related to, of course, events or big data and stuff like that. So for 2015, it was taxi trip analysis. So they provided a data set with like 12 gig. It's not that much data, but just to give an idea, right? with all the trips, the taxi trips for New York in 2013. That's actually public data. It's available for anyone to download. And then based on this data set, you would ingest, you would read this from a file, and then you would provide an answer to these two questions, right? So what are the most profitable areas, and what are the most frequent routes? And then as part of the challenge, they also, of course, explain all the details about what exactly they mean by profitable areas. So for example, you need to calculate like a window of time for empty taxis in a specific area, and then calculate the average of the fair amount for that particular area. And then, there is some math involved in order to actually define what they call profitable area. And then for the same thing for the frequent routes. So the routes, they just provide you the raw file with the latitude and longitude, and then they actually ask you to split in like in a grid of cells those latitude and longitudes, and then you define per cell like what's the most profitable cell, right, or route. Of course, looking for funny pictures. This is the funny picture that Google Images provided to that challenge. I'm not sure, again, why I still do that, but then again, a lot of funny pictures from taxi drivers, and of course now let's try to get them together, right? So the key features here that we used to implement this solution, of course, was async event listener, which is then this queue-based listener that we have as part of Geode. It can be parallel or serial, so depending on the needs, of course. Let's say that you do care about the order of events over throughput. So then, of course, you would request, you would use a serial async event listener. But let's say, of course, that you are more focused on performance, then, of course, you'd go for the parallel, right? The API, it's very, very simple. It's pretty much that interface, and then you have this method called process events, where you get like a list of the events that you are going to process. And then to define the batching here, what you can do, you can specify first, actually, for the listener itself, you can specify the number of threads that you want to be processing concurrently. So that's another way to kind of do a more parallel processing here for the data. And then for the batch and the queue size, you can define a batch size and a batch time interval too. So that's how we actually played a little bit here with the windowing in Geode. And these queues itself can be persisted. So again, using the same mechanism we talked about in the persistence of the regions, right? You can use that for the queues itself. And again, why? Because if a node goes down, you can also restart the node, and that queue, the data that was inside the queue that has not yet been delivered, it's going then to continue from where it stopped, right? That's pretty much the reason. And then you can also set some thresholds around memory as well for the queues. So the architecture that we created here, right? So again, assuming we have a partition region, right? So you have, of course, one entry that goes to one side, and then you have another entry that goes to the other node, and then the replica, of course, is sent to a different node as well. Of course, assuming you have a bunch of those, right? So that's how you can actually scale the system, and as more nodes you have, as more capacity you have here for processing and not only for storage. What we did here, if you have any questions, please just stop, right? What we did here then, you can think of like a few of these taxi trips. We are just grouping them and batching, and then our listener there would do some processing, right? And then from there, decide, hey, for this particular batch, update the frequent routes region with these particular entries. And then we have another client running, right? So we have one client that is ingesting the data, and we have another client that is then listening for all the updates in this frequent route region. So whenever we have another update there, we have a caching proxy region, which is a region that actually keeps the data local here, and it will update the local copies of the data whenever that region frequent routes on the servers get updated, right? We also define an expiration here, so you can define, of course, eviction and expiration for the regions. So for this case, we are saying that the time to live for every entry is 30 seconds. For the devs challenge, like the implementation, they actually ask is like 30 minutes, I guess. But just for the sake of the demo here, we actually are lowering those numbers and doing it a little bit more quick. And then based on the data here, right, this would be one of the OQL queries that you can provide. I'm not sure if the font color is good enough for you guys in the back. But here we are executing then an average, right? And a few interesting things here. So since we are storing actually object here, right? One interesting thing about OQL is that you can call methods on this object as well. So for all the entries that you have in the region, you can call any methods that those classes might have. So for example, here I'm simply calling a toString, and here I have as part of every trip, I have a get fair plus tip method, because in order to calculate the average, I actually need to consider tip as well, right? So very simple, but I think it's just like to illustrate, and then on top of it, I'm calculating that average, right? Then on the client, right, whenever we get these updates, we are also executing a query, but then the interesting thing here is that the client is executing a local query because it has a copy of the data here in this local cache. So I don't need to do a trip to the server to query for data, right? Because I have the interested data that I want here in the client, right? And here, the way we are doing, we are listening for these new entries on the frequent routes is through register interest. So not pulling the server, of course. Whenever the server gets a new entry or gets more data, right? The server sends me that data. I'm not pulling the server to know about it, right? Slightly different.
So your listener's taking a new average every time a new entry shows up for a particular area. Is that what?
No, I'm not doing this query on the bottom here for every update there. This query is manually triggered for now. But that query there is triggered every 30 seconds or every 10 seconds on the client, which is a different query. Does that answer your question?
What are the listeners doing?
The listener here is just sending the data there to the client. I'll actually show the code a little bit more. Few slides, I guess. So just to make it clear, that's something that like a lot of our customers get sometimes different expectations. It's OQL. Sure, it can do SQL like this, but it's not SQL. It's OQL. Just make it very clear. So talking about the regions, right? I mean, a few different things here. So for example, since the frequent routes, we are just keeping there the top 10 or something like that, we can make the region replicated. So we can make the copies available everywhere. And if we, for example, let's say you want to do a more complex query, you want to do joins, for example, that might be one reason to have some regions replicated, right? But then of course the trips, which you actually have like all the data, you can you make it partition, right? So then you can scale on that side. So it's the interest of time. Yeah, cool. Demo time. Thanks. So again, you're starting a live demo. Let me see if that's good enough. So before I actually start,
Of these servers that I
yeah, I have a whole bunch of servers here. Where is our GFish? So I'm shutting down the cluster that Swapnil used before. Let me see if the nodes are, yeah, cool. So we just script everything here, of course, to make sure we're running everything fresh. And I'm not going to show all the scripts in detail, right? But you can see like the step by step, and that's something also that GFish provides. You can actually script the GFish commands in a way that like you can group all the operations it's doing. So for example, the first thing, of course, I'm starting a locator, then I'm starting server 1, and then I'm executing some operation there. And remember that we talked about the listeners and the functions, right? The way to get this code in the servers is to another command that we have called deploy. So you can deploy a jar file that has some Java code that you want to execute in all the nodes. And we distribute the Java files, right, to the jars to all the servers, and we also version them. So you see that there is this #1 in the end, if I actually deploy a new version of the same files, of the same jar files to the servers, it's going to add like number 2, number 3, and then again it keeps versioning all that. So that's another way to distribute code and whatnot. And that also applies to the listeners as well. So here we have the system started. Let me just connect real quick. Hope I need to increase the font size a bit, right? Is that good? So we have 3 members on the server, list regions. We have a couple regions here. Taxi trip, it's empty for now, right? 0 entries. So now I have my client here. Increase the font size. Can I increase the font size? Let me start the client first. So this is the client that is going to connect to the distributed system and keep listening for updates on the frequent routes region, right? So nothing is happening here, and we have this spread that is like every, I think it's every 500 milliseconds, right, the last run. It's going to just print the rank for the most frequent routes, like what's the top 10. It's empty for now. Now we are going to populate with some data, and just for the sake of the demo too, we're just pausing every 500 milliseconds, and we are reading like 10,000 entries for now, just for the demo, right? Let's move to the client here. So now what's happening here, I mean, it's going to print, and the most interesting part will be in the end, but like what's happening now, it's going to print the rank, and it's also printing a message whenever some route changes in the rank. So it's monitoring all the routes and say, hey, this route was actually number 2, and now it's moved up to number 3 because, I don't know, you had like more trips for that particular route. And as soon as it's done, which should be very soon, it's just going to print the rank, and that's what I'd like to show. So there you go. So here you have like, this is the most popular route for these 10,000 entries that I just loaded. So 22 trips. And the route, of course, it's a combination of like where the taxi started and where it actually stopped, right? So you have here the coordinates in the cells for the pickup cell and then the drop-off cell, so both coordinates, right? Another interesting thing about this demo, right, is that the same query we are running here. So Geode, oh, this is the Dabs challenge page. The same thing we are running here in this example, right? So Geode also provide a REST interface, and here we're just going to demonstrate how you can execute simple operations. For example, list all the available regions. So this is Swagger, which is, I'm not sure if you're familiar with this. It's like it's an interface for RESTful APIs that you can then execute a bunch of operations based on your API. So that's built in, that's running on Gemfire, on Geode. So we have like 80, 80, and 81 for the 2 servers that I have running. And I'm just listing all the regions. You can execute like normal region operations, so you can do puts, gets, same thing as like that. But the also interesting part is that you can execute queries, right? So you can save queries and execute queries like by name. Let's say you start a query and then you say, I want to execute query name blah. But in this case, I'm just running an ad hoc query, right? So just for the sake of doing it, right, I'm going to the listener that I have on the client. This is the query that is currently running here, right? I'm just copying and paste, but that's what I had there before. And I'm going to execute the query, right? Oops, I forgot to cast for a string, yeah. So here I'm actually getting an object in the browser, and Swagger is not really happy about it. Let me start another.
Or you can just undo it, I guess, because that would get the old.
It might be
query.
faster. Yeah. Queries. Ad hoc. Oh, that's there. There you go, as key, then value to string, as value. Yes, that will do it. There you go. Now, here's the same result we had before. So that same route and the number of trips. And here is, of course, I'm calling the toString of the objects, right? So I'm just printing all the values from all the objects. And then again, the same query I'm running on the server through REST, I can also execute from GFish. So no big surprise, I guess, but here it is. So like multiple ways to interact with data, right? So from REST, from the client, from the servers. Any questions about this demo? Yes, I still have. When it finishes.
We got about 10-15 minutes.
10-15 minutes? Okay. I can try to run the other quick demo about PDX if you have time.
So
Sure.
what exactly is the most profitable route?
Sorry? What make the most profitable? Oh. That would be interesting. We're actually thinking about that. So we're thinking about submitting the demo here, the implementation for other conferences. But then like one interesting bit would be to actually have a proper UI to actually plot things on the map and like in New York, what's the most profitable area. That might be interesting, but like we haven't done that. I mean,
Yeah, and
UI.
have it updated on the UI, on the map, right?
Yeah, that would be a nice thing, but my JavaScript skills sucks. And I'm happy about it. Anyway, so any other question about this? I'm going to switch topics a little bit. So now, the other demo I'm gonna show, this would be tricky, I guess, because of the font size, but let's see. I guess I'll start with the code. So what we are doing here, right? So Groovy, through Spring Boot, it's very simple to get like a Groovy script and make a Groovy script like a Spring Boot app. And the only thing, of course, so Spring Boot, of course, already packs all the dependencies for Spring, but of course, the missing part here would be the gem file or the Geode jars, right? So Groovy provides this thing called grab, which is a nice way to do dependency management. So you just do this, and it's going to download the jar file that it needs to run this file. So I'm putting here the gemfire core, which is the Geode core library dependency. And then here I have like a very simple application. It's going to produce like 100 entries, and like every time it's going to repopulate and send the same data like every 10 seconds, I think, or yeah, 10 seconds. And then I'm going to start different versions of a consumer, so simulating a client, right? It is going to, again, do a loop and just read all the data from the server, right? That's pretty much all it's doing. But like while I'm doing this, I'm going to change the domain object, right, the Pojo, and add a field, remove a field and whatnot, and see that all the clients, hopefully, will keep running all the time due to the PDX feature that we have. Right? So let's see how that goes. So the first thing here, of course, let me shut down my previous cluster. Yeah. Okay, that's gone. Good. I'm going to start a new cluster. Here I have a much more simple scenario, so I'm really just starting one server and one locator. There you go. List members, just 2, right? List regions, I have person region. And it's empty. Nothing really different so far. So here, I'm going to start the producer, and then of course I'm just pointing to that locator, to that cluster, right? As import, and I'm just disabling web because Spring Boot would start a web container like Jetty and whatnot. I don't need all that. I'm running a console web. So let's start with the producer. So as you can see, we're preparing to send to other conferences too. So here, I have 100 entries, right? And it's not going to change more than that. I'm sending the same 100 entries every time. The interesting thing here, although, remember that I think you asked me the question about how the server understands what version of the domain object, the PDX thing you're talking about, right? So whenever a client connects, we have this PDX type registry information. So this is the information that we have in our registry, right? So we see that this is version 1. That's the first time you're seeing this object. And this is all the fields that I have. So I have like ID, name, last name, and email, right? Now I'm going to start the first consumer. It's just going to, again in a loop, keep printing all the entries there. Of course we are in Seattle, so I was looking for local names. So Kurt Cobain, so here just ID, the name, last name, and email, right? Nothing really different. So I will kill the producer now. This thing is going to keep printing that. And now I'm going to modify a little bit the code of the producer to add another field, so city. So here's just another way to do POJOs in Groovy. There is nothing really different than this. So you just annotate a class with canonical. I'm going to comment the previous version and do the second one. So here, as you can see, I'm just name, email, last name, and I'm adding city now. Run the producer. So here, you see that the registry already identified that is a version 2. So it knows that, oh, I already have an instance of this object. I know this schema, but this is a version 2 of this schema, right? So this client here is still running. And now if I start a new client,
With the updated with the updated POJO.
yeah, oops, did I update the POJO? Oops, so here is, of course, I haven't updated the POJO, right? So what happened here is that for the sake of the system, this client connected to the system and said, hey, I'm still talking view 1 with you. You are a new client, but you only know view 1. So now, let me actually, thanks Rob. Let me update the client as well, to of course understand the new schema, right? So it now understands city. There you go. So the two clients are running at the same time. I'm just adding a new field. So now what I'm going to do is a third client removing a field. So I'm going to remove last name. Let's repopulate. So here, ID, name, email, and city. No last name. So here, of course, they all change to null because there's no, I removed the field and of course the data itself, and I'm not caching the data locally on this client. So this is a proxy client region. It's not a caching proxy. And we have here the type. So this is the third version of the same object, right? And here's the schema. Now I'm going to start a third client here as well. And now this guy also, of course, will not know about last name. Consumer. No last name. So just, yeah, sure. So the three clients are running at the same time, and they only know different versions of the objects, right? Question?
So the insert is what defines a new, or maybe modified that there's a new field, so therefore this is a new version.
Yeah.
Yes. And the query that says, give me these fields in whatever format you said that.
I'm not even querying here, I'm just getting the object from the key, from the map, and I'm printing it. Like the code, it's really just a loop through the region doing a get, and I'm just printing that. It's just a get.
But he knew the server knew you wanted the version without.
Without a certain field.
With or without a certain field by what? By.
When I connect to the server and I say,
yeah,
hey.
He's continuously running. He's always said number two, number two, number two.
Yeah.
And
They're already pre-established. Yeah.
we already established that that's what you're gonna get.
Yeah. Exactly. But even if a new client, let's say a completely new client, let's say it's another department of the company, I don't know. But for some reason they are using the old definition of the object, right? That application would still work, and I would talk with that application the only schema that application knows. So let's say I add a fourth client here that just know the schema of the first one, which is ID, name, and without city, right? That's still valid because the registry keeps history and keeps like the 3 versions, right? So I know that if a client comes and talks to me V1, V2, or V3, I know how to interact with that client.
Which just started with whatever was available.
Yeah.
Or at the time he was reading one, he'll continue to read one. You say you can also have a client that asks for a specific form.
Yes.
That's not what these guys do.
No, they're talking the version they already know. Yeah. But even if I had a new client, the client could do that. Could ask for a specific version.
I don't really need that full version. I'll take it over.
Yeah. For example. Yeah.
You specify that.
Yeah. And the other benefit here, of course, is saving bandwidth too. So let's say that I don't know, we use PDX for other things, even internally too. So we don't need if you don't need to send the entire object to you. I mean, I'm just going to send the fields you care about, for example, right? They'll save some wire too. Guess just to wrap up the slides, then we can still have more questions. So we'll talk a little bit about the roadmap, right? So these are a few things that we are planning to add to the product. Is it circle? So HDFS is one thing that we have. So there is some code for an HDFS connector there, but it's not production ready yet. But I mean, we'd love to hear feedback, or people who are interested could just go to the dev list, go to the community and talk about it, right? But the idea here is that you could persist data using something similar to an async event queue or async event listener that I used here to HDFS, but also, of course, ideally, you'll have some way to recover data from there as well. The same thing we do with disk, right? That's one thing. Off-heap storage, right? So that's actually already available in Geode, the current version. So Lucene search is also something very interesting that's a lot of our customers were talking about and asking, right? And that's now we are adding. So we haven't really mentioned it, but the OQL mechanism we have, it also supports indexes. But of course, whenever you talk about query and indexes, I think Lucene is like that thing that it's a standard nowadays, I think, right? It's very well known. So we'll be adding that functionality to Gemfire, probably to next version, but I can't commit on dates or anything like that, of course. But an experimental version of these APIs are already available in the current build of Geode. So Spark is another thing that we also have a connector to talk Spark, which means that all the regions that we're just showing here, you can query those as RDDs in the Spark land, and then you can just play with that, do your computation using Spark, and then you can then perform or store the result of your computation back in the region as well. So it's a bidirectional connector, so you can read data and write data through and from Geode. And then of course Cloud Foundry service, which is also something that we have and it's already running with Gemfire. Not exactly Geode, right? But so we'd love to get like any contributions from any of you guys. That could be, of course, code, but not necessarily. I mean, of course, documentation, wiki, the website. So people like to fix things in our website, find typos or anything. Sure, go for it. Send our pull requests, but documentations or even the participation on the mailing list, or providing any feedback about the APIs or the stuff we have. I mean, those are all great and valid contributions as well.
So with Spark, the idea is that Geode would be simply another persistent store, as it like you said, HDFS or Tachyon or whatever.
Exactly.
You're not looking at being sort of a distributed in memory as the computations go along. That's the memory instead of the local memory. You're not looking at that.
It could be another way to do it, right? If you collocate the nodes with Spark, like all the data nodes, the Gemfire or Geode nodes with the Spark nodes, you could do that. But one of the things that we are still like, and that's why it's still experimental, for example, the connector we have, is about hashing the data and making sure that whenever you have these worker nodes of Spark processing data, it's really just reading and processing local data. So the hashing scheme that Spark uses needs to match, and it would be nice if it could match what we have in Geode as well to avoid like going for data in a different node, right?
Yeah.
That's kind of one of the.
Yeah, because I understand one of your competitors, Apache Ignites, that in addition to being the persistent store, and all this is sort of magic to me, that they're also looking at being sort of a distributed in-memory store for the computations as they go along.
Yeah, well,
without actually persisting it.
I guess I'm not sure about all the details about their implementation, but the storage of the computations, you could do pretty much the same thing with our connector, which is store the result of that computation or read the input for that computation from a local node along with the worker node of Spark. But keeping that in sync is where things is a bit tricky, I guess. Whenever you change the data schema or you hash in a different way, well, what happens when you lose a node of the storage, right? And then that goes, I mean, in our case, we do the replicas and everything to a different node. What happens, because then the Spark, if a node fails if a worker node fails, right, it's going to restart that computation in a different node, and you have to guarantee, I mean, ideally, right, you have to guarantee that that's going to start on a new node that is the same new node where the Gemfire node replicated the data, right? So you can continue from there. So corner cases like that, that's where the things get tricky, right? Well, like the general use case, it works as is, man, as a persistent storage, yep, or in-memory storage. So of course, finding bugs, as I was saying, anything like that are valid and good contributions. Those are, of course, the URLs, so of course, the website, Jira, Wiki, and everything. This is just, of course, if you are going for the slides, they're all here. You can have all of them at the same place. Thank you very much. I think Swapnil had a talk, but...
Can you speak to like what size data that you folks have typically dealt with? You know, gigabytes, terabytes?
You mean cluster size?
Yeah, just in general.
Yeah, well, I guess we go from all ranges, but most of our customers are actually running big heaps and big clusters. So we can't mention names, but one local shop, local company here in Seattle actually is running, for example, 100 nodes with 120 gigs.
112, 115.
112 nodes with 150.
115 gig JVM. So
JVM heaps.
12 nodes.
That's one example, but then we have like other extreme cases too, as like I think it's India Rails that has like 3 terabytes of data in memory all the time, and then you have the rest archived in disk.
So any challenges with you know, garbage collection and stuff like that with such large heap sizes?
Yeah, that's the key part, right? That's the tricky thing here. We do our best, of course, to avoid garbage generation and everything like that. But for, of course, every use case and every scenario, you have to tune properly the JVM and the GC to avoid garbage collection. So if you have like a read-intensive use case or a write-intensive use case, stuff like that, the JVM needs to be properly tuned for that use
What are the
case.
slides? I'm sorry, that was on the previous picture there. The slides, or which one of those has the slides? These?
Oh, the slides? Oh, I'm sorry. Oh, I haven't updated the URL here with the slides. I'm sorry, but I can send the slides to the Meetup link or.
Yeah, just send that to me. I usually put it up on the Meetup link.
There you go.
Send it to SeaJUG and all that
We
stuff.
did.
So, yeah.
So you mentioned, I'm sorry, you mentioned off-heap memory. I haven't heard of off-heap memory used in Java.
Okay. So well, it's a topic that has been in discussion for like JVM projects in a while. Like we have it I mean, since 2013 for another project, which was Gemfire XD. Cassandra has something similar like that too. I think Spark is also providing their kind of off-heap storage mechanism as well. So the idea is that since the JVM has to deal with all the GC pods and everything like that, you would provide this balloon of memory running outside of the process that then you can manage yourself and not run into the same issues.
So are you doing this with JNI, or is it actually a separate application that you?
It's not JNI. It's through the Java unsafe API and stuff like that. So, yeah.
Just a note, I know you have very excellent production monitoring. Your slides would benefit if you just mention and show as it's a complex system, but all the metrics are there.
Great, thanks. Yeah, that's true. I mean, we haven't mentioned anything like that, but we do expose a lot of information through our JMX API, REST, and we do have our own monitoring framework through something we call VSD and some binary files that we store. So every second we are collecting a bunch of metrics from all the systems. So if buckets move and what happened, when happened, and everything. So then you can plot all those in nice graphs and understand what actually happened with the system. So when dealing with like distributed systems like this, it's very important, of course, to have like all the information you can to troubleshoot any issue, right? Or even to understand how actually your application works. So that's something that we always talk to our customers about, because I mean, sometimes they have some expectations about their system and they are not maybe, I mean, they don't really understand how that will happen in production or in runtime. So I mean, really look at those numbers, look at all the metrics, and then say, oh, okay, that makes sense then. So yeah. Memory usage, network, everything.
Yes. My previous job, we used the Gemfire, and that monitoring found problems in our systems that our monitoring couldn't pick up.
And I'm not giving any money, any beer. Thanks. Yeah, that's great. Yeah, that's true. Yeah, okay, now I do. Right? Now I do.
Speaking of beers, if everybody else has any questions, maybe we'll catch up more beers.
Yeah.
All right, thanks guys. And next month, meet back over here to talk about Polymer and web components for Java developers. So, cool.